Welcome to ClickMyProject.com. Now we are going to discuss about the project Tufts Dental Database, a multimodal panoramic X-ray dataset for benchmarking diagnostic systems. Now we are going to discuss about the abstract of the process. In this process, we propose the application of suitable selected texture discriminated feature for the detection of oral cancers or else the oral lesions in the dental X-ray images, and then classifying the types of diseases. Hence, the support vector machine, that is the SVM, is used to compare and then validate the performance of different feature sets. Hence, the machine learning SVM is used to classify the oral cancers as well as the type of the cancers. The classification accuracy is observed to improve the stability of the features extraction by means of the convolutional neural network algorithm, that is the CNN algorithm. The further improvement in the accuracy is obtained by the application of the classifiers by reducing the misclassifications. Hence, the SVM performs the reducing the misclassification, and then the CNNs will perform to improve the stability of the process. Finally, the performance estimations by means of the accuracy, sensitivity and specificity. By using these three parameters, we can justify our process is efficient. Now we are going to discuss about the flow diagram of the process. This is the overall working flow present in this project. The modules such as input image, pre-processing, segmentation, feature extraction, classification and finally performance estimations. These are the modules we have done in this project. At first, the input image is taken from the dental dataset. The dental dataset having the X-ray images of the dental images, which having both the normal as well as the abnormal images. After taking any one image from the dataset, we just move to the pre-processing. In this pre-processing step, we have go through the image enhancement. In this image enhancement, we have four kinds of image enhancement is there: CLAHE method, HE method, BBHE method and DFHE method. By using this four image enhancement method, we can enhance the quality of the image. After enhancing the quality of the image, we just move to the third stage of the project, that is the segmentation. In this segmentation, first of all, we have applying the thresholding method to initial segmentation. After getting the initial segmentation, the image is converted into one binary format, which means the background will be the zeros, the foreground will be the ones. After that, the morphological operation is applied to fine-tune the images which having the only the affected portions and not having the affected portions, which means the affected portions will be extracted and then the background will be eliminated. After done the segmentation, we just move to the fourth stage of the project, that is the feature extraction. In this feature extraction, we have applied the convolutional neural network to extract the statistical features from the image. After extracting the features from the image, we just go to the classification stage. In this classification step, we have using the machine learning algorithm to classify whether the input is affected or not. If it is an affected one, we have to find out which type of disease is present in that affected portions. Finally, the performance estimation is carried by using the dice coefficient, kappa coefficient, cross correlation and accuracy. Majorly, we have considered the accuracy to justify the accuracy of the classification. Whether the accuracy is high means the stability of the classifier is high. Now we are going to discuss about the running procedure of the process. At first, open the Matlab 2015b and change the current directory. If you want to execute the process, just right click in the main_GUI.m and select the option run. Once you selected the option run, the new user interface was open like this. After that, you can see the several push buttons in the right side for the controlling actions and then the several axes as well as the table in the left side for the display purpose. First of all, click the button input image. After clicking the button input image, there are a lot of dataset is there in the dataset. So we have to take any one image from the dataset. After the selection of the image from the dataset, the corresponding image is shown in the axis 1 with the title of input image. Then we just move to the second step, that is the pre-processing. In this pre-processing, the image is resized into an 256 class 256, and then the image is enhanced by means of the histogram equalization method. So the reason of image enhancement is to improve the quality of the image. The reason of image resize is to resize the image into an aspect ratios to maintain the size of the image. After done the image resize, we just move to the third stage of the project, that is the segmentation. We have already discussed about the segmentation. First of all, the initial segmentation is done to segment the region from the background. After that, the contour segmentation is applied to fine tune that the affected region. Hence this is shows the affected regions. Hence this figure 3 shows the initial segmentation which having the binary region. Then feature extraction. So the feature extraction is done by using the convolutional neural network. The extracted feature values are plotted in the graph format like this. Then the feature we have extracted is like this, which is shown in this table. After that, we just move to the classification stage. So in this classification stage, we have to classify whether the input is affected or not. So if it is an affected, means the type of the disease is shown in this message box. After done the classification, we have to estimate the performance of the process. The overall performance of the classifier is accuracy is 97.5%, sensitivity is 97.1%, then the specificity is 99.2%. The corresponding values are shown in this table as well as in the bar chart format. Thanks for watching this video.